Module 2.6 will discuss extreme events and climate hazards. We have already discussed that changes in average temperature could result in more frequent and intense extreme weather, for example, extreme heat, heavy precipitation, low or no precipitation, and storm conditions and high winds. As you can imagine, if extreme weather is more frequent and extreme, this will also impact the frequency and severity of climate hazards such as wildfires, storms and Sibibusi, droughts, floods, and landslides. For example, drier conditions and hotter weather can increase the risk of drought and wildfire. Extreme precipitation can result in flood events and change land conditions and soil characteristics, leading to landslides. It is important to note that climate hazards can also be called extreme weather events, natural hazards, or natural disasters, and many people will use these words interchangeably. What do we mean when we say extreme weather events will become more frequent? Let's use an extreme heat event or a heat wave as an example. Let's pretend this heat wave event is very rare, with a 2% chance of it happening in any given year. If we do the math, this works out to 2 times every 100 years or once every 50 years. So we could call it a 1 in 50 year heat wave. In the past, without climate change, this heat wave would have occurred on average once every 50 years. So you can see there are 50 dots, 49 are pink, and our one red dot is representing our heat wave. Now let's say we are in the present day and we've experienced 1 degree warming in average temperature. As we can see, the heat wave now has a chance of occurring 5 times every 50 years. If the climate continues to warm and we reach 1.5 degrees of warming, the heat wave now has a chance of occurring 9 times every 50 years, as you can see. With warming of 2 degrees Celsius, the heat wave could have a chance of occurring almost 14 times every 50 years. And if we see 4 degrees of warming in the future, the heat wave could have the chance of occurring almost 40 times in 50 years. That's almost every year in a 50-year time period. Now, think about a family. For a parent born in 1965, they might remember a heat wave that only happened once or twice in their lifetime. To them, this could be the hottest day they could have ever imagined, and they would remember how it felt. For their children, born in 1990, this is something that would occur once per decade, or 5 times within the 50 years. For their grandchildren, this heat wave would now occur about twice per decade, or 9 times in the 50 years. For their great-grandchildren or even great-great-grandchildren, this heat wave could happen almost every year. In just a few generations, the way we experience these once rare climate events is completely different. What do we mean by extreme weather events are becoming more intense? Let's use the heat wave example again. Let's say we have heat wave intensity on our y-axis and the amount of warming on the x-axis. And let's say in the past, the heat wave intensity was at 0. In the present, with 1 degree of warming, a heat wave may be 1.2 degrees hotter than in the past. If we see 1.5 degrees Celsius of warming, the heat wave may be 2 degrees Celsius hotter. If we experience 2 degrees of warming, the heat wave may be 2.7 degrees Celsius hotter than in the past. And finally, if we see 4 degrees Celsius of warming in the future, the heat wave could be 5.3 degrees Celsius hotter than it was in the past. So when we say increasing in intensity, we mean climate change could increase how hot or how intense a heat wave becomes in the future. So what does this look like in real life? As we can see in this graph, global natural disaster counts have been increasing over time since the 1970s. Between 2010 and 2019, most of the natural disasters were attributed to flooding and storms. As the climate continues to change, we could see this trend of increasing numbers of natural disasters continue. Fortunately, we have become better at handling these disasters, for example, through early warning systems and disaster risk management and reduction to reduce the overall damage and number of fatalities. But in the future, we will need to do more to prevent damages if these events continue to occur more frequently, impacting more people and more areas. Let's look at some examples of climate-related disasters in Suriname. Suriname is exposed to a number of climate hazards, including extreme heat, flooding, high winds and Sibibusi, storms, drought, and wildfire. This table is from the Suriname 2021 State of Climate Report, and it highlights historical disasters and damage before 2022 and 2023. So I encourage you to pause the slide and review this table. Do you recall experiencing any of these events? Some of these historically damaging events have been floods. Let's look at some examples. One of the floods highlighted on the table in the previous slide was the 2006 floods in Suriname. The severe flood event in May 2006 occurred in the interior of the country along a number of the larger rivers, namely the Saramacca River and the Upper Suriname River, primarily due to torrential rainfall. As you can see, a large portion of Suriname was impacted by the flood. The government declared a disaster zone on May 8th in the affected areas, mainly in the southern lowlands. The floods caused losses and damage of approximately 40 million USD across the energy, transport, housing, communications, health, education, agriculture, tourism, commerce, and trade sectors. 3 people were killed during the floods, and 25,000 people and homes were affected. Fast forward to 2022, I want to highlight a flood event that many of you are probably familiar with. So in January and February of 2022, there were persistent heavy rainfall, which was unusual for Suriname during those months, but was driven by La Nina. As water levels began to increase, the Staatsolie Power Company Suriname opened valves of the Afobaka Dam to prevent water levels in the Brokopondo Reservoir from rising. On March 9, 2022, rivers began to overflow their banks and villages began to be affected by the flooding. At the offices of the Ministry of Transport, Communications, and Tourism, located at the mouth of the Upper Suriname in the Brokopondo Reservoir, water started to flow in. On March 10th, more villages were affected and flooded, including landing strips and schools. By March 13th, medical posts had been lost in many places in the country. The floods had caused major economic damage and major health impacts. All schools in the affected area were closed. After March 15th, there were several dry days in a row, lowering the water level of the Upper Suriname. On the other hand, the excess water flowing downstream caused flooding in the coastal areas, partly worsened by high tides. The districts most affected were Nikre and Saramacca in the northwest. Finally, I want to highlight the most recent flood event of 2023. These images are from April 2023 of flooding in Paramaribo caused by torrential rain, so you can see the before and after images, and these were captured by Raoul Nyhorst. Thank you for joining us for Module 2, How is Climate Changing in Suriname? Please return to the home page and click the quiz link to test your knowledge on what you just learned. Please note that you have to submit the quiz for all 5 modules in order to receive a certificate of participation. Thank you.